Okay, for next question, it's given that a railway engine weighing 40 metric ton is traveling along level track at a speed of 54 km per hour. So let's write down the information that's given to us. Mass is 40 metric ton and 1 metric ton is equal to 1000 kg. So this is equal to 40 metric ton and 1 metric is equal to 1000 kg. So this is 40 into 10 cube, that is mass is equal to 4 into 10 raised power 4 kg. And now this is traveling with a speed of 54 km per hour on a level track. So speed is 54 km per hour. Let's convert it to meter per second by multiplying with 5 by 18. So this is equal to 15 meter per second. Now this engine is moving on a horizontal track, and on the horizontal track the force required, so this is, let's say, the force applied, and this is the force of friction. So the force required in this case will be equal to, this is the weight that is acting vertically downwards, so that should be equal or more than this as a force of friction. And we know that coefficient of friction is equal to force of friction by r, and in this case the normal reaction is the weight which is acting vertically and downwards. So here the force that is required to pull an engine on the horizontal track is equal to mu into r. So this is equal to, and the acceleration is in this direction, so the force is acting in this direction. So the force required is ma plus, okay, so the force required in this case is equal to or more than the force of kinetic friction, which is equal to mu into r. So this is equal to mu into r, and r is the normal direction which is balanced by the weight. So this is the force required, and let's calculate the power in this case. So power is equal to force into velocity. So let this be P1, that is power required to pull this railway engine along a level track, and the coefficient of friction is 0.1. Mass is 4 into 10 raised power 4 kg is 9.8, and if we calculate the power here, so that is equal to 4 into 1 is 0.4, and we have to multiply it with the velocity, that is 15, and this should come out to be uh, 5.88 into 10 raised power 5 watt. So this is 5.88 into 10 raised power 5 watt. This is the power on the horizontal track. So this is on the horizontal track, and let's move to maintain this speed up an incline, that is inclined plane rising 1 in 49, to up an inclined plane which is 1 in 49. Let's calculate the power. So this is theta, and for every 49 units of distance covered, there is a vertical rise of 1 unit. Okay, so this is 1 unit, this is 49 unit. So in this case, sine theta is 1 by 49, and if we calculate cos theta in this case, which will be 1 minus sine square theta, so that is equal to 1 minus 1 by 49 square. So that should give me square of 49 is 49 into 49, that is 2401. So this is 2401, and this is 2401 minus 1, that is equal to 2400 divided by 2401 square. and if we divide 2400 by 2401, that should be, that's equal to 0.999. So this is 0.999, which we can write it as root 1. So the cos theta is 1. The value of cos theta is 1. Okay, now this engine is now moving up the inclined plane. So the force and the acceleration applied is in this direction. Force of friction or the kinetic friction is in this direction, and the weight is acting vertically downwards. So weight is acting vertically downwards. This is the horizontal component mg cos theta. This is theta. This is the normal reaction r, and this is the vertical component mg sine theta. Okay, so the force in this case, that is F, is equal to, okay, so the force when this engine is moving up an inclined plane, okay, this is F is equal to mg sine theta plus the force of friction should be equal to or greater than. So this is equal to mg sine theta, and force of friction is equal to nu into r. R is mg cos theta. So F is equal to mg sine theta plus nu, and r is mg cos theta. So F is equal to mg is common, so this is sine theta plus nu cos theta. Let's calculate the power in this case. So power is equal to force into velocity. Force is mg sine theta plus coefficient of friction into cos theta into velocity. Let's put in the respective values. Mass is 4 in 10 raised power 4 kg. G is 9.8. Sine theta is 1 by 49. This is 0.1 into 1, and velocity is 15. Okay. So let's multiply this, simplify this. Okay. So this is, let's multiply this whole term with this term. So 4 into 10 raised power 4 into 9.8 into 1 by 49. This is 1 by 49 plus, this is 0.1. So 4 into 10 raised power 4 into 9.8 into 0.1. This has to be multiplied with 15. This should give us the power. So let's try to simplify this. So this is 490 now. Let's cancel this out with 49. So this is 10, 2, and this is 4 to the 8, 8, and this is now 10 cube. So 8 into 10 cube plus this is 4 into 10 raised power 4 into 0.98. This has to be multiplied with 15. So 8 into 10 cube is 8,000, and 0.98 into 4. So 0.98 into 4 should give us 3.92. So this is 3.92 into 10 raised power 4. That has to be multiplied with 15. And this is 8,000, and this is 39,200 into 15. So this is 39,200 into plus 8,000. So this is 0, 0, and 298 is 17, and 4, 4720 into 15. So I have just added 8,000 and 39,200. That gives me 47,200 into 15 will give me 708,000. So this is equal to 708,000 watt, and I can write it as 7.08 into 10 raised power 5 watt. So this is the power that has to be generated on the inclined plane, and this is the power that has to be generated on the level plane. So in the question it's asked what is the additional power required to maintain the same speed up an incline rising at 149. So the additional power required should be the difference of the power on the inclined plane and the power on the horizontal track. So this is P2 minus P1. P2 is 7.08 into 10 raised power 5 minus, and the power on the horizontal plane was 5.88 into 10 raised power 5. So this is 5.88 into 10 raised power 5, and this is coming in watts. So 10 raised power 5 is count 7.08 minus 5.88. So this is 10 raised power 5, 7.08 minus 5.88 is 0. This is 2 and 1. So this is watt, and I can write it as 120 with, let's divide it by 10 cube, which will give us the value in kilowatts. So this is 10 square, and this is now equal to 12000 kilowatt with two decimals. So this is 120 kilowatts. So 120 kilowatt is the initial power required to move this engine up an inclined plane, having the incline rising 149. Do like, share, subscribe. Thank you for watching.